Hello everyone, this is Sheikh John Saida from CHVA section. Today my topic is solar panel management system. This project we have done with an CH Sai Pranit. Let's continue the topic. Let's talk about agenda. First one introduction, second one component required, third one working of solar panel, and fourth one is LM387 voltage regulator we should need it, and solar device charger circuit diagram. And then workings of solar device charging circuit. Let us go into the introduction. The sun is a star made up of an hydrogen and helium gas, and it is radiates an immense amount of energy every second. Solar cells works on the principle of photovoltaic effect. Sunlight is composed of protons or packets of energy. These photons contain various amounts of energy corresponding to a different wavelength of light. Let us go into the components required. Solar panel up to 8 watts and 1000 mAh, micro USB cable 1, and LM317 voltage regulator, and BC5 for NPL transistor, medium breadband, potential meter 100K, and LN5819 diodes 2, resistor 100 ohms and 150 ohms to second one, and 5.6 watts, 1N4734 for a Zener diode 1. The working of solar panel. Solar cells are usually made up out of silicon wafers. The silicon atoms in the solar cells form four strong bonds with their neighbor silicon atoms. By having these strong bonds, the electrons will stay in one place and no current flow is seen. These solar cells usually have two layers of semiconductor. The top layer of the solar cells is dropped with an phosphorus to convert it into to N-type semiconductor, and the lower layer is dropped with boron to convert it into a P-type semiconductor. The N-type layer has excess electrons, and the P-type layer has extra holes. When light particle strikes the solar cell, the photons present in the light will have enough energy to knock the electrons from their bond, leading it is move towards the inside, and the hole formed by the absence of an electron will move towards to the p side. The movable electrons are then collected to at the thin metal present at the top of the solar cell. Let us go into the working of solar panel. If an external circuit is connected to this metal material, the electrons will flow into the external circuit and then reach the conductive aluminum sheet present at the back of the solar cell. The electron then settles in the hole which is present in the p-type layer to the electron cell. Each solar cell has a voltage of 0.5 to 0.6 volts. The solar cell are connected in series to get an required voltage. Usually, 12 solar cells connected in series are sufficient to charge a mobile phone. There are three types of solar panels. They are microcrystalline, polycrystalline, and thin film. In our project, we are going to use an 6 watts 8 mA solar panel, and we are connecting the two solar panels in a series to get a voltage of 12 watts and 80 mA. The below picture shows a single mini solar panel and which can generate output of voltage 6 watts with a maximum current of 80 ohms. Let us go into the LM317 voltage regulator. LN317 is a variable voltage regulator. By using this, we can vary the voltage up to 37 watts with a maximum current of 1.5 amperes. To get the variable output voltage, the below circuit is used. Let us go into the circuit. Solar device charger circuit diagram. The circuit diagram. The circuit diagram shown below consists of voltage and current regulation along with an over voltage protection circuit. The connections are follows. The anode thermal of the diode D1 is connected to the positive thermal of the solar panel, and the cathode terminal of the diode T2 is connected to the input pin of the LM317 voltage regulator. The output terminal of LM317 is connected to the anode terminal of diode D2, and the cathode terminal of the D2 is connected to the cathode terminal of the Zener diode. The anode terminal of the Zener diode is connected to the base and the base of BC557 transistor through 100 ohms resistor. The collector terminal of BC547 transistor is connected to the output pin of the LM317 voltage regulator through an 150 ohms resistor emitter terminal of the BC547 transistor is connected to the GND. The edgest pin of the LM317 is connected to the potentiometer variable and ends on the collector terminal of the BC547 transistor. One of the potentiometer fixed end is connected to the GND. The wire connected to the VCC pin of the micro USB cable is connected to the cathode terminal of the Zener diode, and the wire connected to the GND pin is of used cable is connected to the GND. The working of solar device system. Let's take this is a prototype of our system. Let's go into it. Working of the solar panel circuit system. The working of the solar device circuit is simply is understanding. As first we should place the whole setup in the place where we can get the maximum solar rays to get the desired output voltage from the circuit. Adjust the potentiometer use and measure the output voltage of the circuit. Once we got the desired voltage, be sufficient to the charger and mobile, laptop and some electric devices. And connect to the micro USB to the mobile phone. If there is a proper solar radiation available for the solar panel, the phone will be charged. Let us see how the circuit protect the battery from overcharging before understanding the protection from overcharging. Let us understand a little bit about the Zener diode. Zener diode is similar to the normal diode, but the only difference is that when connected to the reverse bias, a certain input voltage, the Zener diode will start conduction. The voltage at which Zener diode conducts in reverse bias is called as reverse voltage or general voltage. If the Zener diode V2 5 watts connected to the reverse bias and applied into input higher than Vz. A Zener diode will start a conduct even in a reverse bias mode, but the voltage parallel to the Zener diode will always be 5 watts. Now coming to the overcharge protection, if the user sets the desired output voltage by the potentiometer to 5 watts and choose a Zener diode of V2 is equal to 5 watts, the circuit works fine until the battery at the charging ends in below or equal to 5 watts. Once the voltage of the battery at charge ends more than 5 watts, the the Zener diode will start to conduct the reverse bias as per Zener voltage 5 watts. This makes the transistor BC547 to operate the forward bias mode, which cuts off the R2 resistance from a circuit, and the output voltage from our circuit will be 1.25 watts from the formula of LM317. Keep R2 is equal to 0. This voltage is not sufficient to charge our battery. In a way, our circuit will not change the battery once it reaches the required voltage, and our battery is protected from the overcharging.